Hi girls, how are you? So today's lesson, I'm going to just give a little introduction to how to solve problems on changing wave speed. So the previous lesson was about drawing diagrams for what happens when a two-dimensional wave gets reflected or if it goes as from one medium to the other. Okay, now so that's the drawing diagrams bit, but the other thing that you have to do in the next lesson is solve some problems on changing wave speed. So just a heads up of how to do that. So the title is calculating or doing some calculations on changing wave speed. So the thing that connects the speed, frequency and wavelength is the speed of a wave. It's related to its frequency and wavelength. Frequency is f. Wavelength is this Greek letter lambda. So v equals f lambda. That's one way of calculating speed, but there's also one other way of calculating speed, which is v equals distance over time, where v is the speed of the wave and d is the distance a wave travels in a given amount of time. So there's two ways of calculating the speed of the wave. Then the other thing that might be useful in your calculation is a connection between frequency and period. Period is the time taken for one complete wave to pass a point, and frequency is the number of waves that pass a point in 1 second. So f is 1 over t or t is 1 over f. So that's useful for you. So these are some of the useful formulae for waves, but there's a few more because this one has to do with what happens when a wave goes from one medium to the other. That's when its speed changes. So I've just drawn a diagram and I'll explain what this is about. Very similar to the questions you did on light, but there's a few more things over here though. So this black line, the horizontal line, is the division between medium 1 and medium 2. And this red line is a ray, which tells you the direction of the wave going from one medium to the other. And when the speed changes, what does happen is the wave bends, okay, or it refracts. So you have your angle of incidence and you have your angle of refraction. So let's say that's your medium 1, that's your medium 2. So they have different quantities. So N1 and N2 is a refractive index of each of these medium, okay? Could be air and water or whatever, okay? And V1 is the speed in medium 1, V2 is the speed in medium 2 because the speed changes. Theta 1 is the angle the wave makes with the normal in medium 1, and theta 2 is the angle of refraction, which is the angle between the normal and the wave. Sometimes there are trick questions. They give you the angle between, they call this the interface and the wave. So you got to do 90 minus that angle to get the other one. And then lambda. So, and the last one is the wavelength. So the wavelength also changes. When you drew your diagrams, you saw that the waves can get closer when it goes slower, or it can, and the waves can get further apart, or the wavelength increases when speed increases. So lambda 1 and lambda 2 are the two wavelengths. Okay, so based on this, just like you did for light, Snell's law holds good. So Snell's law was n1 sine theta 1 equals n2 sine theta 2. And then you have a few more relationships over here, and that is this one. It is given at in your blue books. I'm trying to find, where is the blue book? Oh, it's somewhere away. Okay, so you also find on the cover page of your blue books these formulae. So n1 over n2 equals v2 over v1 equals lambda 2 over lambda 1. So that's given as well. So how do you use this? There are like three things here. So this one simply means you can use it in any combination. So you can use these two together, or you could use those two together, or you could use the v. You could use the n1 over n2 equals lambda 2 over lambda 1. So how do you use that? So I've just written it out for you. Let's do that one at a time. So let's take you say you take a pair of n, the refractive indices and the speeds. If those two are given, then you can just use n1 over n2 equals v2 over v1. If you rearrange it, it becomes n1 v1 equals n2 v2. Or if you want to combine the velocity and the wavelengths, you can get this V1 over V2 equals lambda 1 over lambda 2, okay? Or you could combine refractive indices and wavelengths, or velocity and wavelength. So you can do any pairs and you can still solve problems depending on what is given. Usually 3 things are given and you have to find the 4th thing. Now, the most important thing to remember about changing wave speed is that the frequency never changes. The frequency stays the same. So it's the speed and the wavelength that changes. And if you have a question on light, what you need to remember is that the color of light depends on its frequency and not its wavelength. Okay, so red light will still say red when it goes from one medium to the other. The red doesn't change its color and becomes something else when it goes from air into water. It's still red. Okay, what does change would be its frequency. What does change would be its wavelength and its speed. So frequency stays the same. So once you've known this, I think you should be able to solve those problems. What I will do is work through those problems and take a photo of the answers so that you can check that once you've done the questions. So let me know how you go, and I'll also make myself available for 15 minutes during each time you have a physics lesson in your timetable so that you can ask me questions. So I'll send you the Zoom link for that. Okay, so bye for now, and I hope the rest of your day goes well. Stay safe. All right, and bye.